So you correctly identified what the problem's asking for. What's the probability of it snowing when you know glaciers are growing? But I'm not quite sure where this formula came from. Bayes' theorem says it should be the probability of snowing given growing is equal to the probability of snowing times the probability of. Excuse me, I'm trying to scroll over. Let me get this going here. It won't let me scroll. So I'll just shrink and move. There we go. So probability of snowing times probability of growing given snowing, which is what you have right here. Okay. Then divided by probability of snowing times probability of growing given snowing plus the probability of it not snowing times the probability of growing. Excuse me. Let me scroll a little bit more. The probability of growing when the glaciers are not snowing. So looking at it spatially, it's your desired branch for the growing divided by all possible outcomes that lead you to glaciers are growing. So you have that branch, and then you have to divide it by that same branch and the other branch. That's what will give you this formula. This may be some shorthand that I'm not familiar with, but nonetheless. So that's step number one. So there's our formula. Now, issue number two. This number here, this 0.03, that's coming from 1 in 29 days. Excuse me. That's coming from 1 in 29 days. You cannot round there. If you round this number to 0.3, you get everything wrong because your rounding is just way off by the end. Your accuracy it just gets destroyed. So instead of rounding this to 0.3 or 0.03, you need to leave it as 1 over 29, and then therefore this number needs to be 28 over 29, because this number here isn't 0.03. This number is 0.0344827586, and that's rounded itself. So you just leave things as fractions until the very end, and then at the very end go ahead and round. Because this problem tells you to round your answer to 4 decimal places. So you can see here you rounded this to 2 decimal places, which is not even give you anywhere close to 4 decimal places of accuracy there. So I hope that helps. I hope that gets you, because it looks like you're on the right track for the problem. You correctly identified what it's asking for. I'm just not quite sure where your formula here, your probability of G for Bayes' theorem is correct. That's the denominator down here. So I'm just not quite sure the numerator. Anyway, let me know. Hope it helps.